I have to admit that I'm really nervous because this is the first time when I speak at such a big conference. I spoke before, but the audience was a bit different, and I'm really happy to be here. It's a line of speakers that is impressive. But one thing did make me sad. There are 2 female speakers out of really lots of speakers. So I'm thinking I know loads of great speakers in London, so I know that female speakers just don't submit proposals, that's the problem. So I'm gonna send some great speakers your way, so please, Devoxx people, review next year is gonna be better, because it feels really weird to be one of the 2 female speakers, but it feels great as well. And I'm happy to represent Sky because Sky encourages diversity. It feels great. For a change, it's good not to feel like you're in minority. So I think my colleagues, after a couple of glasses of wine last night, they suggested things to make me less nervous. One of them, sitting in front row, he said you should walk with a bottle of wine. Don't drink it, but just do it, because no one has done it before. I'm thinking, how is that a good idea? It's 9 a.m. Or Spice Girls pictures with girl power. But I'm not going to do any of that, I'm sorry. I'm going to do something which makes me less nervous and talk about continuous delivery. So I think first I want to informally introduce myself because I don't think, besides my colleagues, no one knows me here. So I work for Sky for a few years, more than 4 years, and I've been in about 6 teams. I like moving around because I like learning new things. So I've done a couple of languages. I like working on infrastructure stuff, deployment pipelines, and so on. I'm agnostic in terms of languages. I want to believe that that's true. And to be honest, the only constant thing that happened in my life lately was change, like constantly changing. But I do like that, and this is new for me, so I'm really excited to be here. I'm going to start with just wanting to present what I'm going to do today, just in case you decide you don't want to be here. We do cool stuff in some of the areas in Sky. I mean, in each area we do different things, and I'm going to talk about the experience that we have in one of our projects and how we build the deployment pipeline. And I'm thinking about practical stuff and things that we've done and how we leverage tools. I'm not gonna, as you've seen from the title, I did mention Kubernetes. So how many of you are using it now? In good number of people. How many of you have you heard of it? Loads more people. It's a buzzword those days, and it's great. What I want to say is that I'm going to talk about choosing a target infrastructure, but I'm not going to go into advanced topics of Kubernetes or anything like that. So if you're here for that, sorry, that's not going to be like this, because I've seen dozens of talks about Kubernetes itself. There is a lot of documentation. What I want to talk is just our take on things and how we've done things. And I'm going to have a demo as well. So I'm going to try and time myself, half talking about the problems and the approach, and then to go into a demo to show you practically what's our take on things. And then the next steps would be hopefully where you come in, because maybe after the talk we can talk about approaches that you've had and where we want to go, and maybe we get your help, open sourcing stuff even. So I'm going to start with the deployment pipeline. So first of all, every time when you start a new project, you have some requirements and constraints, and sometimes they're interchangeable. So imagine that we work on Sky as part of a huge project, the international project, because we are expanding in Europe, and we're going to be in Poland soon. So there are lots of challenges, but there are about 6 major platforms that need to be delivered in a specific time, just so we can integrate. There are time constraints, and we have basically what happens in big companies sometimes. Maybe some of you know the experience. You have a bunch of people like 50, 60 people. You have some teams which they have to work in parallel because according to timelines, all those people need to work to deliver a product. So that's one of our, let's just say, requirement or constraints. So imagine have all those people ready. Then we were thinking, maybe we can split things into microservices. I'm not sure if we do microservices. I've heard loads of talks at this conference about microservice, and I think that it's more like we do split things domain-based, and we do tackle problems based on domain, so we can parallelize work in teams. Whether they are microservices or not, that's debatable. But that's one of the requirements which came from above, is to do microservices, and it makes sense for our team setup. But then we also had to integrate in different languages. Our main technology stack is Java, but we had, for example, an application in Python, which we inherited, was really good, partially because I worked on it, but that's not the only reason. But we needed to integrate it in the platform. So when you have different technologies, when it comes to deployment pipeline, you really need to think about how you're going to do it. You don't want to end up with two completely different deployment pipelines. So that is quite a big requirement. But then it comes the really big one. Target infrastructure, where do we put the code? I know I work with people that do code and commit and don't care where the code ends up. And he says, oh, it's somewhere in the cloud, it's doing something. I'm not sure what, but I don't care. In this project, we really want to, from the beginning, we were thinking, how do we enable developers kind of develop a culture where everyone that commits some code thinks about the quality gates and where it ends up and how it acts in production. Does it perform well? Does it scale? Is it suitable for the business? Because that's one of the main requirements. So, but the fact that the target infrastructure can change, that's a huge constraint. Why can it change? Well, you know that big companies use, for example, Amazon Cloud Solutions or other solutions. Sometimes they become expensive, and then we try and do in-house infrastructure. And there was a project which was running in parallel for that migration to happen from Amazon to an in-house infrastructure, but we had no control over that. There was no resourcing that we could control. So imagine deploying somewhere, but you don't know exactly where your code is going to run. So you need to decouple from your infrastructure. That's the point. So we had no, traditionally speaking, ops resources available. So how do you deal with that? Those are all very important questions that we needed to tackle. And trust me, I don't think it was very easy. So I'm going to start with the first thing that we did. We said, if every team starts and define their own way in getting to production, we are in trouble. Like, we have to standardize the pipelines. And that's where, that's where the idea is. If you have, let's just say, we have mostly Java applications. We said we need to unify the way we build and deploy things. So we're using Gradle at the moment. So you have loads of sub-modules in Gradle saying, I have a service which I want to get to production. I have a demo application which I don't need in production. Maybe I need on some demo environments. And I have some mocks. And those needs to be deployed on the stubbed environments. So how do we define those standard pipelines? Each team should use the same path to production, to stub showcase, to stub environments, etc. Otherwise, we're going to be in a pickle. And people are going to step on each other's toes. We are talking about 50, 60 people here just ready to start on work. So we said, first thing we do, we standardize pipelines. Then we try and automate those pipelines. Because if you have a standard and if you have an input, like the name of your project and so on, and your project can specify what pipelines it wants, then you can automate. We also, when you automate, you have the pipelines ready. But we have the target infrastructure moving underneath us, so we need to decouple. So what we said, it needs to be independent from the platform, the deployment pipeline. I don't want people going in a continuous integration server and fiddling with the scripts of how they deploy. And then, obviously, the pipeline should be, as I said before, if we have Python and Java application, it should be independent of the technology. And that's, again, another, idea which we thought it was great. So if you have a Java app, then use Gradle. If you have a Python app, build a really thin Gradle wrapper around it and make it deploy and make it seem like a Java app. So I thought that was a great idea. So this is a typical path to production for our applications. And I know that everyone in this room has a slightly different understanding of what continuous delivery means, because for some people, continuous delivery means I commit in 2 minutes or whatever my builds are taking, this code is going to production. But you have to think about your business requirements and what works for you. So we said, let's start. This pipeline did not look like that when we started working on it, but because it was automated and teams weren't actually fiddling with the pipeline, it evolved without disrupting. But that's how it looks like today. So basically, we said, after you build your application, you run your test, we work containerized, which I'm going to get in a second. You build your image and push it to a test repository. You have a certain quality gates where you run NFT, stubbed NFT for your component, or functional test in a deployed environment, which we wanted to have, or integration tests for all your components. After that, you have a release candidate. But for us, it was enough if we ended up with the code from commit to a stub showcase environment, where we could showcase to the business, to the technical analysts, etc. And then daily, we had a job which deployed this code on a new environment and run some tests in, we call it canary environment. And that for us means it's a production environment. So what it does, it takes, we're still working on this, it takes part of production traffic, and if it performs well, the next day, that code gets into production. That's what continuous delivery means for us. And is maybe similar with some other approaches, but it's good to mention that once you commit, it's not like your code is going to get straight to production in the next 5 minutes, but that was enough for us to start like this. We don't know if the pipeline is going to remain like this, but for now, it seems to be working. And imagine starting from zero, not having anything, having a bunch of people trying to deploy somewhere we don't know where, and suddenly you could start and think about various steps of how you want to get your code to production. I'm going to come back to that, and in the demo, you're going to see exactly how the Jenkins jobs, because we are using Jenkins, look like, and how you can get your code into production in a real example. The next thing, what you see here on the screen is the YAML configuration for some projects. So we thought, when you spin up your pipeline, I said earlier, I want my application to take control of what pipeline I want. And in this example, I have a Devoxx service. As you can see, I specified that the pipeline is of time production. So when I'm developing the application, I'm dropping this file in my project structure, and that's how I instruct the project that builds the pipeline. I want a pipeline of type prod. And I want some additional stuff, like monitor some namespaces. We have some standards there of how we monitor. We hit an endpoint, which is common for all the apps, and check that they're up and running. I want some mocks, which I need a pipeline of time mocks, and I have a demo application, which doesn't go to production because it's just internally for us. So we said, if the applications could specify something as simple as a YAML file, and then the production pipeline and the other pipelines would be built based on that, that would be great. And I'll show you in the demo exactly how that's happening. So in terms of tools, we have quite a different culture in this project. It's not like we do appreciate the tools that we have, but the tool could be great sometimes, but if you don't know how to use it or it doesn't suit, it's not great. So we chose the tools which we knew how to leverage. And we worked with Jenkins before, so we did choose Jenkins for our continuous integration servers. There were other alternatives as well, like Travis CI. And one of the reasons is because Jenkins has a groovy DSL plugin. DSL, I'm sure that almost everyone here knows what it is, domain-specific language. So it's purely used for automating the creation of your builds. So I'm going to show an example of that later. We have a Jenkins jobs generator based on the input which you've seen on the previous slide, the YAML. We have a custom project which just uses DSL and spins up the pipeline in Jenkins. And then we do use Docker, not only for our applications, but we use it for Jenkins master and slaves. For example, for the purposes of this demo, I wanted to be able in 2 minutes to spin up a new Jenkins server based on the images that we have and just work with that. For us, Jenkins is something that can be replicated as easy as an application. So we use containers for that. So those are the main tools. But remember, we customized some of the code. Whenever we use something which is open source, we try to fork it and then enhance, do what we need, do a pull request, and that's how we contribute. But we do have some in-house software which helps us to build a continuous delivery pipeline. So this is an example of DSL for Jenkins. This is, I took something from their documentation and basically adapted for this demo. For an example, it's really easy and groovy to say, I want a job and I want to have an SEM with some sort of Git repository. I want some triggers, and the only step that I have for this job is a Gradle task called CI build, which this is one of the steps which we have in our projects as well. So it's very easy to use DSL, and obviously I'm not going to insist on that because there is plenty of documentation which you can find online. Just to summarize the deployment pipelines, we want apps to specify the pipeline type. Then, very important, as you're going to see in the demo, I do specify all the steps that my application needs to go through, but I'm not going to enforce the application to implement the step in a specific way, because you have to give the teams the flexibility to implement their own tests and get the application to production. And obviously, we have a jobs project or plugin which actually builds the pipeline. So that was the pipeline bit. And you're probably wondering, so yeah, you have a pipeline, where do you deploy? So as the title says, we're using Kubernetes, and I'm going to explain a few things about it, but just really briefly, I'm sure you've done container-based deployments, but this is a crucial shift in containerized deployments thinking, where your application and your libraries and whatever you need are packaged together and are deployed on physical machines. I don't want to depend on the underlying infrastructure. And that is what we leverage, let's say, from containerized deployments. For us, it's cheaper. Like our domain, we build a commerce platform. It's one of the platforms in the big project. We could at any point have a new application. We need to bootstrap it really quickly. We discover we need to do something, I don't know, ship some stuff and we need a new project, or I don't know, a business domain evolves really quickly, usually. So if we need a new application, containerized deployments it's really cheap for us. And also imagine that we have Python and Java app. Imagine having an infrastructure where you remember, oh, I have to install this stuff for Python and then for Java, and then it's a mix and match. And if you do containerized, in our setup, remember, loads of teams working in parallel, just give the responsibility to the team to build whatever they need in that image for the project and just ship it. And the infrastructure should support it. So that's the idea. And then from containers, we said we're going to have loads of those Docker images that run in containers. So how are we going to manage them? Remember, we didn't have the luxury of having, let's just say, ops resources or DevOps. So we kind of took responsibility in our teams. Our culture was that each developer needs to know how to test its code, to deploy, and so on. It was very challenging. Right now, I'm working in the team that is kind of overarching and responsible for evolving the architecture, and it's really, really tough, but it's a really interesting job as well. And we thought about loads of options of how to manage the containers, and various spikes, and research was done. And we chose Kubernetes because it's very popular. It's been developed by Google. So it has really good reputation and really good implementation examples. And Kubernetes is basically orchestrates all your containers. It gives a lot of things for free. A lot of things which I'm not going to go into today, but I'm going to explain the basic concepts which we need to basically for me to support this talk. But I highly recommend that you go and read more about it, and the other systems which do the same thing. They're very interesting, and they give a lot of things for free, like service discovery. They schedule your services on different nodes. Obviously, it does self-healing deployments, auto restarting, and replication, and scaling up and down. Because in a platform where you have microservices, people have talked before in a couple of talks, basically what we want is the ability to scale up or down a part of our system. And that happens for us as well. Some of them are really critical, they take loads of traffic. Some other parts of the system are not so critical. So Kubernetes helps us a lot doing that. So I draw a nice diagram. I think this took me more than the rest of the slides, just the diagram, because I'm really rubbish at building diagrams, but I think it looks, can you see it in the back? Yeah, great. It's just that I spent so much time on it. And basically, the main concept, I know that lots of you here have read about it, so I'm not going to spend too much time, but I do want to say the basic let's say, architecture is you have a master node, and then you have your nodes, which are your physical machines where you deploy your application. And obviously, the master node has a kubelet info service and has different kubelets on each node to communicate. The master node is the one where you would connect using a RESTful API to do your deployments, which we do. And yeah, the other nodes is where your application gets deployed. There is a really interesting concept that they came up with when they designed the system, the concept of a pod. A pod is a unit like your deployable, actually. So if I want my application to be up all the time, I would say I want X number of replicas, I want 3 replicas, and those pods would be your replicas, which gets scheduled accordingly on different nodes, on different physical machines. In pods, you can have multiple Docker containers, but there is a really subtle thing which they say in the documentation, that if your application, your Java application runs in a container, you wouldn't put 2 of your applications, 2 of your containers in the same pod, because that defeats the whole purpose of you scaling up and down, because you can only scale horizontally by scaling up the pods. So why would you put 2 of your applications in there? We use 1 container per pod approach, but if you have something that runs, let's say for logging or something else, and you want to stick it in a separate container, so it's isolated for the other container, then you can do that. But the idea is your application, your main container, 1 container per pod. And that is pretty much what I wanted to say about Kubernetes. It's great, and I think for me, I'm still learning how to use it and how to deploy. But the main ideas for us is how do we actually deploy on Kubernetes? I did say that we use Gradle for all our applications, including the Python one. We wrap them. So we developed an in-house Gradle plugin, which, to be honest, we didn't open source the code because it's very specific to us, but that's not the important point. The important point is the idea of having a plugin that abstracts all the packaging, publishing, everything from your projects. I basically don't want to have any deployment scripts in Jenkins or in the applications. None of the teams should do that basically in different ways and manually. So this Gradle plugin, which I'm going to show in the demo how it offers tasks, is going to encapsulate all that deployment basically scripts and information. So just to summarize how we build things in our project, we have a pipeline generation concept. Everything is automated, no manual changes on the CI server. We have standard quality gates, but very importantly, those quality gates are not defined. We enable each team to implement their own quality gates. So if I have a functional test quality gate, it's up to the team how they want to implement it. Some of them have extensive functional tests which involved, I don't know, Cassandra or other things. I don't need to worry about that as if I was working in a platform team and try to help the development teams. So there is flexibility to implement, and that really scales because that enables us to have work for all the teams while still maintaining a standard deployment pipeline. And it does work for different technologies. And our aim was that new applications should be bootstrapped easily. So the Jenkins jobs project, which we have, basically you specify the repository which you want to add as a pipeline and the type of pipeline, and it bootstraps it for you. And then obviously the last thing that I mentioned was the deployment abstraction. So don't worry about deployment scripts everywhere. One plugin does all the work, and then the applications just use the tasks that the platform gives. So I'm going to go into a demo because I think there is a lot of information, and those things are quite new because this is how we do things. So the way I decided to approach the demo today is because I had problems before with VPN at conferences, and I had to connect to internal clusters and internal Jenkins, which I spin up for my tests, and I know is very difficult, and demos can go wrong. I decided to screencast the demo, and trust me, that was not an easy task. Even with my VPN from home, from London, the internet was crap, and it went down all the time, and I couldn't connect. It was not an easy task. But I did screencast because I want to fast forward through the least interesting stuff, and I want to basically be able to explain what I've done. So we're going to work with IntelliJ, command line, and Jenkins. And there is one thing which worries me about this demo. I always work on this dark background, and I'm not sure if you can see on the back. That's why I asked the guys, thank you, to dim the lights. And if the font is not big enough, I can zoom on stuff. It's not a lot of code that I'm adding in there. It's more for you to see the idea. Wow, I can't see anyone. This is great. Thank you. You guys can see me, right? I mean, in the spotlight. I've always dreamed about that. So I'm going to start with the demo. So hopefully it's not going to be disruptive, but this is QuickPlayer, so I'm going to go through it. So can you see in the back? Oh, great. Thank you. So basically, I have a main Gradle project with a submodule, and my submodule, which I'm trying to deploy, it's a Devoxx service. And the build.gradle file, it has a simple action release for versioning, because we use that when we tag our Docker images, etc. And K8 plugin dependency, which is our platform plugin. Sorry, I'm just going to pause here for a second. You can see Jenkins has nothing, just a bootstrap pipelines job. That is basically the project which we have. So I added, prior to this, my GitHub repo of this small application. So then I can run the Bootstrap pipelines and get a pipeline. But before that, I was telling you that I need to add, and that's what I'm doing here, I need to add a CI configuration. So I'm going to add a CI YAML file, which would simply say Devoxx service is of type production. Okay, just so you know, the demo is about 18 minutes, but I'm going to skip through build and stuff like that, so it's not going to be that long. So all I'm doing is say Devoxx service typeline prod, and then I'm going to push that to my GitHub repo, which I've configured already in the Bootstrap. So then we should see, so here I'm just committing. So I'm going to go a bit faster. Okay. And then let's just run this build. I want to show you one thing while this build is running on the screen. I'm trying something at the moment. I'm trying to use the Kubernetes plugin for Jenkins. This is what I've been working on the last few weeks, trying to make Jenkins non-disruptive. And you can see a new slave here, which is automatically created in Kubernetes, where I'm running my build. So that's what I'm trying at the moment. So if someone has used it before and it works for them, maybe they can let me know. So I'm going to fast forward through this Bootstrap pipelines job, and then hopefully we would see a nice pipeline defined basically, well, I know you're going to see because I screencasted this. There's no point to say hopefully. But basically what happened here, you can see that suddenly I'm in a new job here. The Bootstrap just created me a job saying build Devoxx Kubernetes pipeline demo is the name of my top project. So then let's see when this is built, I should see a bunch of jobs automatically. By the way, I didn't fudge anything. The only thing that I've done is, The only thing that I've done in that Bootstrap project is add my GitHub repository, and that wasn't very interesting for you guys to see. But other than that, I haven't done anything on the Jenkins. So I have a bunch of jobs created. There is nothing in monitoring because I didn't specify, but I do have a folder called Devoxx service, my submodule, and these are all the builds that the Bootstrap were building for me. So I think that's pretty cool, including Canary and production, whatever I explained in the path to production initially. I'm going to pause here for a second. The thing is, you could see exactly what I explained on the diagram. We have different quality gates. We have the build, test, We have build, test, release candidate, and then we deploy to showcase. So you can see Canary and production here because this is not part of our daily continuous delivery pipeline. So I'm just highlighting those integrations. Then we can have a look in the actual builds to see what tasks our application needs to implement. And I think that's when it gets a bit more interesting, because if I was a developer on this project, this is the first thing that I would do. I would bootstrap my app, and then I would see what did it create. So all those jobs are created, and I'm highlighting the fact that first thing I need to do is implement a CI build. And then I'm looking at some other build to see, for example, what is functional test doing. So those are jobs which mainly have one Gradle task. There is nothing in there that prescribes how to implement. Okay, so I have to implement a CI build and a CI functional test. Obviously, I'm not going to go and implement all the tasks in there because that would be repetitive, but you get the point. So as a developer, I would go back to my application. Let's see. Yeah, so I'm implementing the CI build task. That's the first thing that I would do as a developer. And probably, I'm going to fast forward through this a little bit. What I'm doing, I'm just saying, hello, I'm building. And then for the functional test, hello, I'm testing. That's what I would do when I start implementing my application, just to see what happens with my pipeline. Can I get the builds green? Can I get to production in less than a day? I think you can. I'm going to let you think about it and see if you were to work on one of our projects, if you could get your app in production for, I don't know, half day. I think you can. So I said we're using Gradle, and I'm using Gradle wrapper to explore all the tasks. So I have some basic release tasks, the tasks that I added, and I'm running my brand new task here, and I say, hello, I'm building, but maybe in a real app, I wouldn't like to do just that. So I'm saying, I've been keep talking about the platform plugin. The platform plugin, aka the K8 plugin, we named it, gives us a lot of promotion tasks. So I'm gonna pause here for a second. In the previous image, I was showing you the tasks that I had available in Gradle. Just by applying the platform plugin, I have a bunch of tasks like build image and so on. We use Docker. So our plugin builds us an image. What it does, it builds using Docker, it tags it, and then you have tasks like promotion tasks to push images and promote those images. So it abstracts all that logic out from the application, which I think is really cool. So I have a bunch of tasks that maybe I want to actually reuse in my steps. Okay, so let's see what I'm gonna do next. Probably I'm gonna try and say, depend on build image. That's what you would do when you build your application. You would run some tests and you would build the image. Cool, but maybe I want to explore a little bit more of what this platform plugin is giving me. So I'm double checking that is indeed functional test. And then let's see what else we have. I'm gonna put the normal speed on. This platform plugin, basically what it does, it's allowing applications to say, look, I want to push images to these repositories. So here, I'm giving a list of repositories. Those are names of some of our Docker registries. Basically, the platform encapsulates the address to the registry, and you configure what repository do I want to push. I just want to pause here for a second. When you build your artifacts and you push somewhere, it doesn't matter how you do it. We use Docker. You still need to know where. But we didn't want our application to know what's the address of the registry or whatever we're using, so we encapsulate it in the platform. If I'm specifying a repository which doesn't exist, the plugin on the same registry, Docker registry, it creates me a new folder and I can deploy there. So that's the whole idea. Abstract all the details of where I'm pushing my artifacts and how I'm deploying it in a plugin. So let's see what else I can do. I'm gonna start and say each of my applications has to have specific environments, right? Let's say I'm working on a part of a system, one of our domain is entitlements, and one is subscriptions, Sky subscriptions entitlements. Maybe my environment in Kubernetes needs to be isolated because I'm stubbing. I'm stubbing for functional test. So here, I'm saying I want a Devoxx functional test environment. Namespace is a concept from Kubernetes where you can isolate your pods. I'm deploying my application and I want to isolate it resource-wise from everything else. So here I want a new namespace in Kubernetes. I want a repository which pushes my image, and I want a context. Kube Control is one of the tools which you use to connect to Kubernetes, and I'm saying I want a context called CirrusCore. That's the name. Our name is Cirrus as a team. I want the context to be CirrusCore, so I want that cluster. That's what I'm saying. So I'm gonna pause here for a second. We didn't have any deployment tasks, but because I configured the plugin to say I want to deploy to an environment, which I'm calling Devoxx functional test, it gave me automatically a deploy to Devoxx functional test task. So I don't know how it's going to be deployed, but I have that available. So you could see how I start to build up my app and deploy it in various environments. And I'm actually going to show, there is no point for me to go back and forth, commit, run the builds, etc. So I'm gonna try and deploy from local, which was a bit crazy when I've done that over VPN. So I'm gonna try and use the Kube Control here, the tool that I'm saying. In any in Kubernetes, we use kubectl to query what's happening on the clusters. We have a couple of clusters. Test cluster, the one that I've been working on is called Zero Score. Even in screencasts, things can go wrong. I just realized that by splitting the screen like that, you won't see. What I'm doing now, and what it would happen automatically, I'm going to pause here for a second. What it will happen automatically in our project is when I want a new namespace in Kubernetes, I would add it in a repository, and it would create it automatically. But for the purposes of this demo, I wanted to show something in Kubernetes, how you create a new namespace. In Kubernetes, everything is really like imperative. You give it a YAML file, and you say, create me this resource with this specification, and it happens. And I think that's the principle which we use in our CI configuration. I have a YAML file. This is what I want. Please provide for me. So I'm defining a namespace called Devoxx functional test because I need somewhere to deploy. That's okay. So then I'm going to try and use kubectl to. This is the options that you have for the kubectl tool, and then I realized that you won't be able to see, so I'm splitting the screen vertically. Cool. I had a few takes of this one, but nothing is perfect, not even the screencast demo. So I need to be in the right directory so I can access the namespace YAML, and I'm saying create using namespace YAML. So I have a namespace now. So I have a sort of space with resource allocated for me. I'm not specifying any quotas for CPU, for memory, because it's too much for this demo, but you can do that. So now I'm going to access the namespace using kubectl. So this is actually connecting to Kubernetes cluster, one of our internal cluster, and this is where I was worried about VPN. I'm trying to get the pods. There's nothing, because I haven't deployed yet. And I'm going to try and deploy. Okay, so I'm just double checking that the name of the environment where I said namespace is the same as the namespace which I created. Again, realistically, the namespace, I would add the configuration in a repository and run a Jenkins job, which gets triggered automatically and it gets created. But I wanted to show you this. So I'm going to use deploy to Devoxx functional and try to deploy my application, which does nothing at the moment. I don't even have a Docker file, so it's not an image, because I thought that many people in the room would know about Docker, and I don't want to build an image. So it failed. There is another concept here, which I want to explain. When you deploy, you have all those tasks, and you can deploy on different environments. But how do you specify how many replicas you want, how much CPU, and how much memory? We said this is another thing which applications should control, teams should control. So this is where the pod configuration comes in. I need to have a pod configuration in my project so I can then deploy. Okay, so I'm adding the pod configuration here. It's very similar to the namespace YAML configuration, but I'm going to show you what you would say. You have some container specification. I'm going to give it a name to this container. Now, this is a bit sneaky because I'm using app name. I know that our plugin takes the name of your module by default. You can override it, basically. And the image would be whatever image you specify in the, for example, sorry, I just need to explain this. When I configured the plugin, I said I want a repository, which is Zero Score test, for example. So the plugin, what it would do, it would try to find the latest image on that repository and deploy it. So that's what image means. And also I'm specifying that my application has CPU, one CPU, and some memory, okay? So now I'm going to try and use this configuration. So again, the control for specifying what the pod is is gonna look like is in the application. I should know. I should know how much memory my mock is taking, or my demo app, or my production service. It's not something for the platform to resolve for me. So now I'm watching what's happening in that namespace. Yeah, I just realized at that point that I was watching nothing because I wasn't using kube control. So kube control, cool. Let's see what's happening when I try to deploy. I'm using a task which was generated automatically for me, and now I'm trying to deploy. This is how I would do it if I was a developer and I'll start a new project there. Okay, so let's see. Cool. So it's starting by adding a replication controller. I think from here, you kind of get the point that by having all those tasks added automatically for you, I didn't wait for it to create pods and etc., because that would take so much time, and you wouldn't be able to start the pod anyway, because I don't have an image. So probably in your functional test, you're going to say, I'm depending on deploying to an environment, and so on. I continued this demo for a minute or so while I'm talking to you. I said I'll just leave it in the background. So basically the next thing that I would do, I would add another environment, and that would be production or stop showcase, etc. But I think you get the idea how iteratively you can get your application deployed up to production, having a pipeline generated automatically and having the deployment tasks already generated. That doesn't mean that you cannot specify what each task is doing, or you cannot specify what your application quota is. So that's pretty much the demo that I had today for you guys, and I'm gonna, hopefully you've enjoyed it. I'm going to go to, I don't have much time, so I'm going to go to next steps. If you want to ask me any question, please grab me after this. I won't be around for long. I'm gonna try and fly back to the UK if they actually allow me now. But I want to say that the next steps for us is to improve Jenkins, to improve the pipelines, and make it non-disruptive, and using the Kubernetes plugin. So if anyone is using and wants to give me a hand, please do. Open source a part of the plugins which we have. We cannot do everything because we have specific configuration just for us. And then we want to improve the Jenkins jobs project that generates the pipeline to be a bit more easier than, we don't want to just go in and add the repository so it bootstraps. We want maybe to configure it so it accepts some input. So yeah, there is a lot of work to be done. I think I've been told by someone before this talk to say that the Huntley password is Sky1 with capital S. I think it's very creative, so I need to say that before I finish. And I have some sources. Obviously, you find a lot online about DSL and Kubernetes and Docker. Very inspiring, and thank you very much.